Alright, welcome back everybody. So today we're going to take a look at point clouds using ParticlesGPU, and we're also going to take a look at how to render ParticlesGPU particle systems using PBR rendering techniques. I've done a couple works with this that I put on Instagram over the last couple months, so you may have seen those, and I'm pretty excited to finally be able to share this with everybody. So let's jump into things. Now, here's what we're going to be building. And if I just press play, we can kind of see that we have a point cloud that then begins to deform itself. And we can see that this point cloud is rendered quite nicely using boxes that are oriented appropriately given the particle's direction. And this reflective material is being used, which actually reflects kind of the overall scene that we have in the background. So we're going to look at doing all of this. And we're going to start from scratch, so let's get into it. So I'm actually just going to delete all of this, and we can start over completely from scratch. So the first thing, we'll need a point cloud, and so I'm just going to use a SOP, and I'll just start with a sphere. So we have a sphere SOP. Then I'm going to use a sprinkle SOP, and then I'm going to drop a null. Now we're going to use a SOP to chop, and I'm going to copy and paste that and turn off position and turn on normals. We're getting an error because we don't actually have those normals, and we want to compute surface attributes on our sprinkle to add those normals for us. So it is probably worth noting here that you can, of course, use any SOPs besides the sphere. You can also use your own geometry and load in a file, or when we do this next step, which is a simple chop to top, and we'll make that RGB, and we will fit our rows to channel set wrapped. Now, this gives us a texture, and we'll just copy and paste that and drop the normals on. I'll use Alt, click and drag for an annotation, and I will call this SOP to point cloud texture. And there we go. So you could, of course, just kind of skip straight to this texture if you are using your own input point file or an EXR. But for right now, this will be good for us. So next, I'm going to select that out of here, and so I will call that select position, and then we'll drop our normal on here, and we'll call that select normal. Now what I need is a particles GPU from our palette. And where is it? There's a lot in the palette now. Here we go. ParticlesGPU. And now we can start actually just making some changes here to be able to get our particles going. So first, we want to simply wire in our particle source to the position, and then find the velocity and input the normal there. Now I'll just drop down a null and view this, and we can start to make some changes. Thankfully, there won't be that many changes for us to make, but there are some. So first, I want to turn off these external forces. I'm going to turn off that external magnitude. And then also turn down this turbulence magnitude for right now. And when we reset, we can see that now our particles are kind of being birthed right in a sphere shape, which is exactly what we would expect. Now, there are a couple things that we don't love here. One of them is the material. I'm just going to make it squares for now, because I think it's a little bit easier to see what's happening. But one of the things that you'll notice is that we're actually kind of losing particles because those particles are being birthed and then dying, and you can see this a little bit better if I throw in a point transform and maybe just increase the scale a little bit, and then I'll reset this. There we go. So now our sphere is a little bit bigger, and we can see what's going on. So because we're doing a point cloud and not a particle system, I don't really want these particles to be birthed and dying. And I also want to make sure that the position and the normal are associated with the same particle. We don't really see that too much right now, but it will become more apparent, especially once we start working with our PBR. So to make some of those changes, we'll just jump in our ParticlesGPU. First thing I'm going to do is just turn off these remaps because those will scramble our inputs, and we don't really want them scrambled in this case. So the next thing that we need to do is turn off the kind of automatic updating for our life, and then we also want to remember our initial position in some way so that we can actually begin to use that initial position for kind of like a resting location, and then we can make our particles seek that resting location if we want to. So I'm going to edit and split my screen here, increase this a little bit, and here we go. So I've done a bigger tutorial about the ParticlesGPU component in the past. If you're not familiar with this at all, you should probably take a look at that because it'll make a little bit more sense with some context. For right now, I'm just going to kind of go through exactly the changes you need to make, and so you can follow along. But you probably do want to take a look at that other tutorial if you haven't already, unless you're already familiar with ParticlesGPU from other sources. Last thing, this is the 2023 build of Touch Designer, and ParticlesGPU has had some updates. So the line numbers might be a little bit different if you're using an older version, but you should be able to figure out the intent pretty easily. So the first thing that we have to do is stop our life from updating. And so I'm going to drop a render select and put my GLSL multi-particles as the reference top. I'm going to turn this to input 1. And the reason that I'm using input 1 here is because our particle life buffer is the first index, and that's what we want. So this is basically render selecting our life. I'm just going to open the viewer there, press N so that I can see all of this, and we can see then basically that our life is indeed decreasing, and we don't really want that. So what I'm going to do is scroll the whole way down here to where we're actually outputting our life right here. And instead of outputting the actual lifetime, which is being decreased every frame, I'm just going to output this maximum life, which is going to effectively not change the life of our particles at all, which means they will no longer need to kind of die and then fall out. And we should expect to see that if we reset this. Okay, so we can see that these particles are indeed not dying, but we don't have all of our particles at once, which isn't really what we want. And so what we should do is take this number of points and actually first change this to total number of particles, and then use this number of points parameter from our sprinkle and drop that on the number of particles. Now when we click reset, all of our particles appear at the same time, and we see that they are no longer losing their alpha and dying over time. Now, we probably want to make a parameter, so I'm going to take this sprinkle and just drag and drop this number of points here on my parent operator, and so then we're going to have a number of points parameter, and I'm also going to make the range a little bit higher. So now we have 1,000 up to 100,000, and I'll set it at like 10,000 for now, and we can reset our particles. We can also see that our size is 10,000 by 1 for this point texture, and so that's kind of all what we want it to be. While we're at it, I'm just going to drag and drop this reset parameter onto the parent as well, so that we can access that. And I'll just leave these over here in case we need them later. So that was a decent bit of our change. There's really only one other thing we need to do, and that is optional, but I like it, and it is to add in some sort of rest position knowledge, meaning we keep track and remember the initial position of all of our particles, so that once we start adding forces back in, like let's say turbulence, make it like a lot higher, and turn up the period. Once we start moving particles around like this, we might want them to then be able to go back to the position they came from, since it is a point cloud, and you think that that geometry has some meaning. So to do that, we can jump back into our particles GPU here, and all we really need to do is add one function, which is going to be pretty straightforward. Now I'm going to go up pretty close to the top and kind of drop this in right after my spawning function. And the reason for that is because I want to use, oops, sorry about that. I want to use a little bit of the spawning function code to be able to help us out. So I'm going to call this a void function, and we'll call it SeekRestPos. And in here, what we're going to do is keep track of initial position, find direction from current pose to initial position, and then add this direction to particle velocity or force. Okay, so the first thing that we can do is keep track of the initial position, so I'll call that vec3 rest pose, and then here we can just scroll up a little bit and actually use this function right here, text, using text start pose, and then sampling this text pose vector. So I guess really quickly what this does, if you control F it, and let's make it case sensitive and find the first one. The next one. Okay, so this is the function, and so basically we're just using this as a wrapper for texel fetch, which means that you'll be able to basically just do the texel fetch function a little bit faster. And so it'll take in a type, which is just the index of the buffer to look at, and then ivec2, which is the coordinate to look up. So let's scroll back down to our SeekRestPos function. Now we'll have another vector3, we'll call it direction, and this, what we can do is use our gParticle.position minus restPos. Finally, we can now kind of convert this to a strength, and so we can do this by using the length and just taking the length of our direction. Now, this will let us only apply this force if there is a strength there. And the reason for that is because we want to use a little bit of normalization, which doesn't work if the length is 0. So we can say if the strength is greater than 0.001, maybe just like that, then what we want to do is set our direction equal to the normalized direction vector, and then we can multiply that by the square root of strength, which will add a nice little fall-off curve to the strength of this seek position force, What that means is when it's closer to 0, this force will be smaller, and that's good because we don't want the particles kind of zigzagging and ping-ponging it with a high frequency very close to their rest position. And so then what we can do is just subtract this new vector from our gParticle.force with gParticle.force minus equals dir, which is now normalized. And then the last thing that we need to do is basically just add a parameter for this strength. So we can come up here, add a uniform float, u seek rest magnitude. Then we can take that and actually just add it here. And then go into our GLSL itself, add that as a vector, and we can go in here, seek rest magnitude, and we'll make that a float, and add it to our parameters. There you go. So now let's take a look. It looks like there's an error. Text pose is an undeclared identifier. And that's fine because I think this should actually be gParticle.textPose, which we can find by looking at the struct. Okay, that wasn't quite it. Then we can go back down to our spawn function and actually just look at what this text pose is up here. And we can just copy and paste that into our function like this. Now we have another error, and that is a conversion from vec4 to vec3 in line 428. And it's because I should have just taken the first 3 channels of this vector. And so there, now we have a nicely kind of recomputed shader. We can reset this. Now what we should try and do is turn up our turbulence magnitude, which, you know, at this point I should probably just make that a parameter as well. And maybe make the max there like 20. So turn that way up, and then we can turn that down and turn our seek rest magnitude way up, make that a range of like 10, and we can see if this is actually doing anything. Now it's not at the moment, but that's because we forgot to actually call it. And so I will scroll the whole way down to this update function. I'm just gonna add it here, call my SeekRestPos, and now we can see that our point system is indeed responding. And if we turn up the turbulence a lot again and let our particles kind of get a lot of whack, then we see that we can indeed recall them to our home position, which is great, meaning that this point cloud can reassemble itself whenever we want. Now, all of these particles are turning, which is fine, but we want to make a little bit of a nicer render, and that's going to be step 2. So to stop this turning, we're going to go to Forces tab and turn this rotation type to none. That means there's not going to be any rotation put in right now, but we can then go and add it back with our PBR render setup, which we're about to do in just a second. So yeah, I think now is probably time to start doing that. I'll just keep this over here so that it's kind of there, but I don't think we really need it. Oh. Whoops. I don't think we really need it displayed. What I do want is another null, which I'll call ParticlePos. And now we should start working on our render. So first I'll do Alt and drag, and I'll call this particle system. Obviously this is optional, but I like to keep things pretty organized. And so now what we should do is start working on our render setup. So the first thing we'll need is a box, and we'll make that size 1 by 1 by 3. So we have kind of like a long skinny box. Then we can use an attribute create. Make sure to create those normals and tangents. Let's use a texture, which we'll come back to, and then a transform at the end, and we can make this uniform scale something smaller, like a 0.1. And now I'll drop a geo using the middle mouse. So this geo, we'll call it geo points. That'll be great. So now let's set up the rest of our render network. To do that, we're going to use an environment light because I want this to be a PBR rendering pipeline. We can use a render top. I will right click on this little icon using the function store toolbar to open up this parameter window. Click on my render resolution, drag and drop that, bind new par as master, and then we can set this to be whatever we like. In my case, I'm going to say 3840 by 2160, but make sure that you have the computer ability to do that, because if you don't have a beefy computer, you definitely want to keep that much lower, like 1920 by 1080, or even 1280 by 720. Okay, what else do we need? We need a camera, so I'm going to use the camera viewport from the palette, which is harder to find. I think they added a lot to the palette or something. Okay. Control B to open and close the palette. And there we go. Now we have a camera viewport, which I will just drag and drop onto the render's camera parameter. And now we're getting started with things. So for, let's say, for our environment map, you can use Polyhaven, and you can download some environment maps, HDRIs, for whatever you're interested in, and use these as environment maps. So I have one, I think it's actually this one, that I've downloaded and that I'll be using. You should download it yourself because it's pretty big files, as you can see, but there's also a ton that you can browse. So I'm just going to drag and drop this in from my downloads, and there we have it. And we'll use Alt-N to drop a null. I'm going to call this env-map for environment map. We'll drag and drop that onto the environment map parameter of our environment light. Now, we'll turn on this render, and we're getting closer. We need a PBR material, which I'll also just drag and drop a null, or Alt-N for a null, and then drag and drop that null onto my geo as the material. And then last thing we need is a substance, which you can just use the simple Touch Designer inbuilt substance. You can use maybe the metal version. You want to make this resolution like a lot higher. It'll be a one-time calculation, so it doesn't cook every frame. And then we probably want to turn down the scratches and the dirtiness and the roughness quite a bit. Okay, so now, actually, I don't think we need this anymore, and I'm going to clear these out to clean up. So now we kind of have the baseline of our render setup, but obviously we need to get the actual points. So I'll turn on instancing on my geo. I'll drag and drop this particle position first. We'll use RGB for that particle position, and already we can see things are working a little bit. We can drag this pivot distance on the camera, so I'll zoom out a little bit, and now we can start to see our point cloud. One other thing that I like to do is to use a skybox, and so for the skybox, it's actually very simple. We're just going to use a sphere and drop a geo down right after that sphere. All we're going to need is a constant material, which we will use our env map for the color map of, and then we'll drag and drop that on our geo. Now we can just make this a lot bigger. That might be just a little bit too big. And the idea is that it can be kind of outside. Oh, there we go. It needed to be actually even bigger than I made it. The idea is that this will now wrap around our entire world, encompassing our camera and our point cloud, and this will kind of just function as like a backdrop, which is nice because it adds a lot of ambiance. You can also, if you want, make this brighter by just increasing this color. So like that looks nice for the moment. And yeah, so now we're starting to get there. We need to get some data out of our ParticlesGPU texture to do the rest of our instancing. So for that, I'll use Alt and the left black bracket to split my screen. Then I will kind of click in to my ParticlesGPU, and on this side, I'll get my geo. We want to use this rotation op for our rotate. We want to use size, and actually I'm just going to grab the R channel for both X and Y, and the reason for that is I don't actually want to distort my boxes too much because I want them to remain small and kind of boxy, and so I'm just going to do like kind of like a uniform scale. So there's a little bit of variation, but not too much. Now, on the Instance 2 tab, we can take our velocity texture, set this to positive Z for the rotate 2 vector, and then take R, G, and B as our vectors. We'll close this for now, and let's open up these parameters, turn off this SeekRest magnitude, turn up our turbulence magnitude a little bit, and start to see what we're working with. Now you can turn up the environment light, also using this dimmer. That'll be kind of the environment light as it's applied to these boxes, which will be different than the skybox, because the skybox is using the constant, and the constant is not affected by the environment light. Now, I guess I'll make a little annotation here and call this skybox. And while I'm at it, I will just grab this, this render parameter, make that as a master bind, and then just call it render skybox. So now we can turn that on and off, which is great. And then I'll call this PBR render. There we go. And this is really starting to come into things. You can obviously take your use this transform, make the boxes much tinier if you like, or really, you know, anywhere in between, whatever seems nice. I guess maybe like that looks pretty good for right now. You can also increase the points a lot and see how that looks different. Turn up the turbulence magnitude quite a bit and start to see our system come together. I kind of like a turbulence period of around 2, maybe like 3, because I think it has not too much detail, where like if it's a very small period, they're kind of all going crazy. but if it's too big of a period, then it seems like they all kind of move in the same direction. So I like something around 3. And yes, we can always then balance that out with our SeekRest, and we can see our points kind of come back into this position. We can also have both of these turned on, and then we have kind of like a turbulent cloud that always stays close-ish to its original form, which is also pretty fun, especially if we are using kind of smaller boxes. Something like that, I think, is pretty nice. Okay, I said we would come back to this texture, and the reason is some of the substances that you may end up using are actually going to have some like visible artifacts depending on what the texture mapping is. And so there is, well, here, let me see if I can find an example very quickly. Yeah, okay, so this is a substance file that I've used in the past, and I'll just drag and drop it on here as my substance top. Input values, turn these down. And then I guess I'll turn my environment light down a little bit for this. And then I'll turn up my resolution quite a bit. And it is actually a little bit hard to see the artifacts showing up here. I'm sure especially once the compression comes through. But anyway, if you do see artifacts, an easy way to try and fix that is just reducing the texture scale by like quite a bit, which will essentially make the artifacts so high frequency that they will likely not really appear. So I'll just go back, I'll put the substance top back on. You can, by the way, in Polyhaven, you can find textures as well. That's where I got the texture that I just mentioned. Metal, it's one of these. So you can just download that, and after you download, just drag and drop and use those textures, or substances rather. So I guess I'll turn that dimmer back up to 2, which means, you know, maybe I should make it a parameter since I've changed it a couple times now. There we go. And yes, I think that's a great place to stop. So now we have created a point cloud from a SOP or any input geometry that you want. We then used the ParticlesGPU component to kind of visualize that point cloud as a particle system, which then allows us to add in easy stuff like turbulence. You can obviously also use attractors and all of the other effectors and the good stuff that you can use and are familiar with in ParticlesGPU. All of that will obviously work with this point cloud based system. And then finally, we took a PBR render pipeline and applied that to our particles to achieve this really nice reflective looking particle system that we can, at will, kind of make go crazy.